Welcome back. This is the enhanced MOSFET. In enhanced MOSFET, we don't have any channel, so there is no question of reverse applying the voltage. You have to apply voltage as positive only to develop a negative channel. So there should be a minimum voltage. There should be a minimum voltage required to start the channel. That is VGS threshold. Okay. After this only the conductivity is possible. Okay. In this region, there is no possibility of conduction. Okay. So if it is a P channel, it is like this. If it is an N channel, it is like this. For a P channel, as channel is P, we should induce a positive. So negative VGS should be applied to induce a positive channel. Here positive VGS is applied to induce a negative channel. I hope you understood the channels. And this is MOSFET acts as a, no, we will see how MOSFET acts as a amplifier. Okay. So before going to that, we should understand the characteristics of these things clearly. Okay, hope you understand this characteristic. First, we will see how the MOSFET acts as a amplifier in case of D MOSFET, that is a depletion type MOSFET. See here, this is the D MOSFET. Okay, D MOSFET. If you want to make MOSFET to act as an amplifier, we are not giving DC voltage to the gate. Instead, we are applying AC voltage. Why we are applying AC voltage means, I already told you we can apply plus VGS or minus VG, plus VG or minus VG for the D MOSFET. So if you give plus VG, what happen? So this is plus VG. So this is VGS. This is VGS axis. This is ID axis. This is the time axis, right? And these characteristics are called transfer characteristics. Transfer characteristics means drawing characteristics between input and output quantities. VGS is input quantity, ID is output quantity. These are called transfer characteristics. If you draw characteristics from between two input quantities, that is VGS and IG, that is input characteristics. If you draw characteristics between two output quantities, that is IDS and ID, these are called output characteristics. But we are drawing characteristics between input and output, that is VGS and ID. So these are called transfer characteristics. In transfer characteristics, we are applying some positive gate voltage. What happens? Negative channel is induced, so conductivity increases. If you are applying negative gate voltage here, so current reduces. So here also current reduces. Again we are increasing this negative value. So here current again increases. Hope you understand. If you apply this type of sinusoidally varying AC voltage, what happens? So there is a sinusoidally varying AC current, but we are giving very small AC voltage waveform here, and we are getting a large change in drain current. If you apply this current into this resistance, what happens? I into R equal to V. Okay, load voltage. So if you are giving small amount of small AC voltage at the input, we are getting large AC voltage at the output. This is nothing but amplification. I hope you understand what is amplification. How this is amplified. Okay, how this is amplified. And this is time axis between time and input. This is input voltage. This is time and output. This is output voltage, and this is between input and output. Okay, these are transfer characteristics. This is input voltage and this is output voltage. Input voltage has to be projected on transfer characteristics in order to obtain output voltage characteristics. Sorry, output voltage waveform. Understand? And one thing you should know, this is the positive voltage, this is the negative voltage, but this is not the positive current and this is not the negative current. Okay, the current is same because this is current axis. So here current is 0, here current is maximum. So this is the maximum current, this is the minimum current, not this negative current. This is minimum current, this is maximum current, as simple as. Okay, now how a E MOSFET, enhancer MOSFET will act as a amplifier. Let us say here in enhanced MOSFET, what happen, the characteristic starts from here, right? It is something like this. Okay, it starts from here. Okay, so as we are applying some load, this is the load line. Load line means what? If the voltage is very high at this point, there is no current. If VGS is maximum, we are applying positive VGS is maximum, we are applying, there is a maximum channel current. This is the maximum channel current. If positive voltage applying is below VTH, this is the minimum channel current. Okay, so that's about these characteristics. And IDS, so BD, IDSS, ID by, so ID equal to VD by RD. So its value is maximum at this point and its value is 0 at this point, and this is called load line. Load line means characteristics between output voltage and its current. Okay, this is the load line. VD by RD, VD by RD is ID. VD by RD is ID means this characteristics is between output voltage and output current. Okay, that is VD, between VD and RT. This is the load line. Okay, sorry, between VD and ID, this is the load line. Now the intersection of this is called a Q point. Okay, now how it works as an amplifier? If you see here, there is no connection between these two. Okay, but whereas in this case there should be some connection between these two. Why? Because there should be some minimum threshold voltage VTH is required in order to form the channel. Okay, so for applying the minimum voltage, we are applying VD here. Why? Because this is a zero voltage, input voltage, zero input voltage. These points are for zero input voltage, it won't conduct. Okay, if you want to transfer the whole waveform to the output side, it should be clamped to at least VTH. Means this voltage should be at least somewhere here, and this maximum voltage is somewhere here, and this minimum voltage is somewhere here. Okay, so your minimum voltage, this point should be somewhere here, and this maximum voltage is somewhere here. Okay, then only we can project this waveform from this side onto this, so minimum to maximum, like this. Okay, and let me draw this one. This is P, this is time. Okay, so if you project the same on here, you will get a output voltage like this. Correspondingly, you will get a output voltage like this.